Now let's turn to page 106 and take a look at the structured question 24 altogether. So here, the question says that we have a hydrated nickel sulfate. So put it right here, nickel sulfate, and it's hydrated, but we didn't know the number that's in front of the water. It says this one has a mass of 2.287 grams, right? Was heated to remove all water of crystallization. The solid remaining has a mass of 1.344 gram. Alright, solid remained. Remember, for the reaction, that if that is going from hydrated to inhydrated, what do we remove here? We should remove water, right? I will use minus here to represent remove. The water is removed, and what should be the final product? Think about it. It will be anhydrous nickel sulfate, right? So here should be NiSO4. Now we know the two mass here. What's the question asking about A? A is to ask us to calculate the value of integer x. Alright, so let's work out A first. Remember, if you don't know how to do it, the first step is to calculate the mole, right? If I want to calculate the mole, I have the mass. What else should I need here? It should be including molar mass here, right? So that added up all the things together, it will be 58.7 plus sulfur is 32.1, and then plus 16.0 times 4. If I type in the calculator, this one would be 58.7 plus 32.1 plus 64. This one would be 154.8 gram per mole, right? Are we being able to calculate the mole for nickel sulfate? Remember, what's the formula to calculate mole? It will be mass over molar mass, right? How about I put it here? Yes. So now we use 1.34 for a gram divided by 154.8 gram per mole. The answer should be 8.68 times 10 to the power -3, right? Remember, how can we denote the scientific notation into the numbers? Oh, sorry, let me write a unit first. It says -3, right? So we move the decimal numbers to the left by 3. Then our decimal will be here. The dot will be here. Then, this one will be 0.00868, right? Mole. And let's take a look at the ratio of the nickel sulfate and hydrated nickel sulfate. If I have like 1 mole of nickel sulfate, I should have 1 mole of hydrated nickel sulfate, right? Because these two stuffs should be exactly the same. Now I know that the number of moles of nickel sulfate will be 0.00868 mole. What is the question asking about? Calculate the value of the integer x. Yes, so if we have the mole, we have the molar mass. If we have the mole, we have the mass. Can we calculate the molar mass? So let's deduce one formula if you forgot how to get it. It will be mole equals to mass over molar mass. So now right hand side, that is divide, right? If we want to move it to the left, it will be times. Then let's move the molar mass here. And then left hand side, it should be like times 1, right? If we move to the right, this one will be divide. So mole and molar mass are simply switch position here. The formula will be like that. Mass over mole. Alright, let's put the mass over mole in the table here. This one will be 2.287 gram divided by 0.00868 mole, right? 2.287 divided by, the answer would be 263.4 gram per mole, right? So now, if we have the molar mass, right here, if we have the molar mass, probably a different color then, green. If we have the molar mass of hydrated nickel sulfate equals to 263.4 gram per mole, and the molar mass of anhydrous nickel sulfate is equals to 154.8 gram per mole. Can we calculate the mass for water here? What's the difference between the above chemical formula and the lower chemical formula? It should be the number of X H2O, right? So if I use like the number of, I will use capital M to represent the molar mass. The molar mass of nickel sulfate XH2O minus the molar mass of nickel sulfate, right? It should be the mass for XH2O. If we do it in this way, it should be 263.4 minus 154.8. The number should be 109.6. Is it correct? I just calculated by my head, so sorry about my mind. If it's 263.4 minus 154.8, the answer would be 108. 108.6. Alright, we have the molar mass for XH2O, and the question asking about the integer x. So here, this formula, I would say it's using this number to divide it by molar mass of simple hydrogen, simple water, right? The molar mass of simple water, it should be 2 times 1.0 plus 16.0 equals 18.0 gram per mole, right? Now, we have the molar mass of X, like the X represents a number, H2O. And also, we have the molar mass of simple H2O. Can we calculate the number of X? So we should use 108.6 gram per mole divided by 18.0 gram per mole, right? This one is similar to the one that we using like U over K, like unknown divided by known, or you can say like probably will, but this one is not molecular formula. It would be better if we use just simply U over K. So U represents this one, and K represents our water here. If that is correct, then we should be able to find our ratios. The ratio is like 6.03, and because ratios should have to be a whole number, right? So we'll round the number to 6. Right, then this is the answer for part A. We know that the hydrated nickel sulfate, the X number would be 6. I'll say the integer X is 6. Alright, B. It says suggest how a student doing his experiment could check that all water has been removed. I think I've discussed it with you guys in the lab worksheet, right? If you don't remember, go over to lab worksheet, turn to page 3. Then you should be able to see like question 4. How could we weighting by using show the reaction is complete? Similar to that one. So this one, we have like 2 marks for this one. You're right. Firstly, repeat heating the solid, and also check that the mass is unchanged. Remember the crucible and the drawings I did with you last time during the tutorials? Like firstly, we'll weight the crucible, lid, and all the products together, and also heat it under the Bunsen burner again, and then we reweight it. So if these two numbers are the same, then it proves that all the water has been removed, or you can say all the reaction here is complete.